This question concerns whether 1 over n squared minus 9 has a terminating decimal expansion. Here, n squared minus 9 must not be 0, and n must be an integer. Well, there's a general result. The reciprocal of a non-zero integer has a terminating decimal expansion if and only if the integer divides a power of 10. That's 10 to the power j, where j is an integer which is at least 0. That probably fits in with your experience, but it actually requires proof. So let's do that. It's not 0, and well, let's suppose the k divides a power of 10. What does that mean? So there is an integer m such that k times m is equal to 10 to the power j. Now take reciprocals, put 1 over each side. So it tells you that 1 over km is equal to 10 to the power minus j. Now, 10 to the power minus j is, well, it depends what j is. If j is 0, it's 1. If j is 1, we're looking at 0.1. If j is 2, it's 0.01. In general, it is 0 point, a string of zeros, and then 1, except for the first case. But all of these things are terminating decimals. So this has a terminating decimal expansion. So let's take this and multiply it by m. Now, 10 to the minus j has a terminating decimal expansion, and multiplying this by m, if m is a positive integer, it's just the sum of copies of 10 to the minus j. If m is a negative integer, it is minus the sum of various copies of 10 to the minus j. And when you add up finitely many terminating decimal expansions, you get a terminating decimal expansion. And it doesn't matter if you stick a minus sign in the front. So either way, 1 over k is, in these circumstances, representable by a terminating decimal expansion. Now let's look at the situation the other way around. We suppose that plus or minus 1 over k, to make it positive, is either 1 or 0 point, and then a finite number of decimals, and then it stops. Well, as you know, if you multiply a decimal expansion by 10, you move the decimal point 1 to the right. So if we multiply this by a suitable power of 10, we can move this decimal point over here and turn it into an integer. So there is a 10 to the power j such that plus or minus 1 over k multiplied by 10 to the power j is m, where this is an integer. Now we can multiply this equation by k, and we obtain that plus or minus 10 to the j is equal to an integer times k. And that means that k divides a power of 10. So we proved it both ways round. So we get to the question itself. We're interested in 1 over n squared minus 9, where n is an integer in the range 0 up to 2025, but for obvious reasons, we mustn't let n be 3. So this factorizes. And this will have a terminating decimal expansion if and only if this number here divides a suitable power of 10. Now, how can that happen? These two numbers are 6 apart, and each of them can only have prime factors which are 2 or 5. No other prime factors are possible. Now, since they differ by 6, only one of them can possibly have a power of 5 involved. The other one has to be a power of 2, or minus a power of 2. And in the range that we're given, there are really not so many powers of 2 or minus powers of 2. Since n can be as small as 0, n minus 3 might be minus 2, could be minus 1. N minus 3 can't be 0. N minus 3 could be 1 or 2 or 4 or blah, 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 up to the biggest it could be would be 1024. So these are candidates for n minus 3. Then you'd look at numbers which are 6 more than that and see which of them only involve 5s and 2s in their prime factors. Then you could begin again. You could look at the numbers n plus 3, where n is ranging from 0 up to 2025. And look at which of those are powers of 2, and this time we don't have to worry about minus signs. And they are, well, actually, these numbers here are too small, but 4, 8, and so on, up to 1024. And in each of those cases, you could look, just simply inspect, to see whether you subtract 6 from that number, you get a number which is only divisible by the primes 2 and 5, or 2 or 5, but no other primes. So when you've done that check, you get these values of n. They're exactly the ones that work. So, for example, when n is 1, then actually n minus 3 is minus 2, which is fine, and n plus 3 is 4, which is also fine. They're both only divisible by powers of 2. 2, on the other hand, 2 minus 3 is minus 1. That's okay. 2 plus 3 is 5, which is only divisible by the primes 2 and 5 at most. It doesn't have to be divisible by both. Let's go on and look at the biggest one, 253. What happens with 253 is that if you add 3 to it, you get 256, which is famously 2 to the power 8. On the other hand, if you subtract 3 from it, you get 250. And 250 is 5 times 5 is 25, and then times 10. So it's only got 2s and 5s in its prime factorization. And the others are all the same. So that's an exhaustive list of all the values of n in the range which do the job.